Hello everyone, welcome back to another GIS Mathematics lecture video. And in this lecture video I want to go through some examples of solving for the inverse of a matrice. So to recap what we have sort of two tools in our belt. We have this idea that if it's a 2 by 2 matrix, right, if it has A, B, C, D, right, if it's a 2 by 2 matrix, we can get a inverse by simply using the following equation, right? 1 over AD minus BC times, so this is scalar multiplication, times D negative B negative C A. Right, so the key thing here is that this must not be 0. Right, because you can't divide by 0. That's not allowed. The other thing we have on our tool here is that if it's not a 2 by 2 matrix, right, we can do this thing where we augment our matrix that we have with the identity matrix of the same size. And if we do reduced row echelon form, right, we're going to get back the identity matrix now on the left side of the augment and our inverse on the right side. And we said that if this is not I, the matrix is not invertible. Right, and we went through an entire video where we talked about these two concepts, and I have an entire video proving that this one works if you're interested. But let's go ahead and let's go through an example that we can use this first theorem on. So let's say we have a matrix. Let me give myself a little bit more room here. Let's say we have a matrix that looks like this. 3, 0, 0, 7. Okay, we have this nice matrix here. It's a 2 by 2, so we can use our theorem 7 from the textbook, which is, again, that's this idea here. So we have A, I'm going to label everything here really quick in a different color. Let's use red. All right, we have A, B, C, and D, just so that everyone can see sort of where the numbers are coming from. All right, A, B, C, and D. So let's do the math really quick. Let's just confirm first that AD minus BC is not 0. So AD minus BC, A is 3, D is 7, B and C are both 0. So if we make sure we explicitly say that we're multiplying here, if we do the multiplying, right, that's 21 minus 0 equals 21. So this is obviously not equal to 0, so we're good there. We can move forward. We have a check. This is invertible. Right, we know this is invertible. So let's go ahead and quickly walk through what that will look like. So 1 over 27, right? That's our scalar coming from this part up here. Right, this is the bottom part. To prove it's invertible, we take 1 over that, times our matrix of D, which is 7, negative B, which is still 0, negative C, which is still 0, and A, which is 3. Okay? Or sorry, that's 21, not 27. 21. That's going to make a huge difference in our answer. Okay. So let's go ahead and do the math here. So scalar multiplication means we multiply each element by the scalar. So we end up with 7 times 121, which is going to be 7 over 21. That's still going to be 0. That's still going to be 0. And we end up with 3 over 21 as well. So these are both fractions, and we're going to leave them as such, and this would be our answer. So hopefully that makes sense, and hopefully you can see how this is much easier than doing the whole augment, reduce row echelon form extraction thing. So this is how I would approach this problem. And because this is not equal to 0, we have an invertible matrix and we get this is our A inverse. So hopefully that makes sense. And if you have any questions, please reach out. Thank you. Sorry, I actually want to go back and address one thing here, and that is these two fractions, they are technically reducible. So the answer could also be presented as 1/7 and 1/3 and 1/7. I did not bother to reduce these. So if you were a little bit confused, you can reduce them. Hopefully that makes sense. As always, reach out. Thank you.